Welcoming you all to my lecture series in the course Advanced Graph Theory. This is Dr. J.Jayapriya from Sathyabama Institute of Science and Technology, deemed to be University, Chennai. In this lecture series, I am going to give a glimpse of what is a graph, the origination of graph, and the types of graph, followed by some results under it. I am going to highlight about what is a graph, types of graph, and then the path, cycles, trials, followed by adjacency matrix, incident matrix for a graph, an independent set, and then the vertex covering. So, before starting with this, I have to just say about what is a graph theory. So, graph theory is a branch of mathematics concerned with networks of points connected by lines. And this subject had its beginning in recreational math problem, and it has grown significantly in the area of computer sciences, chemistry, operational research, and social sciences. Coming to the history of the graph theory, it was traced in the year 1735. So, because of the problem of this Konigsberg. So, what is the Konigsberg problem? Let us peep inside what is a Konigsbergbridgeproblem. A puzzle concerning the possibility of finding a path over every 7 bridges that span a forked river flowing past an island but without crossing any bridge twice. So, the problem is about there were 7 bridges connecting 4 cities. The problem is to walk through all the bridges exactly once, traversing all the cities, entering all the cities. In other words, the person has to walk through all the bridges exactly once. So many people tried, and they were able to say that they couldn't able to walk. So this was the conclusion by, but what this Leonard Hardward Euler, what he has done is, in the year 1735, the Swiss mathematician Leonhard Euler, he presented a solution for the problem, and he concluded that it's not possible to walk through all the bridges exactly once. This was a bridge actually. He viewed this as the cities as the vertices and the bridges as the edges. So you can see there. So Konigsberg, it was a city on the Pregal River in Persia, and the city was occupied 2 islands including the areas on both banks. So you can visualize this situation here. So the problem about the Konigsberg is that whether they could leave home, cross every bridge exactly once and return home. So this was the problem, and he viewed this graphically by placing all the cities as vertices. So there were 4 cities, and the 4 cities where he placed it as X, Y, W, Z, and he made a graph. You can notice here. So all the bridges are identified with the edges E1, E2, E3, E4, E5, E6, E7. So the vertices are identified, the cities were identified by the vertices W, X, Y, and Z. And he concluded that since every vertex is not of even degree, so you notice that this X, there are 3 edges adjacent. So E1, E2, E6 are adjacent to X. It means that the degree of this vertices, he defined the degree of the vertices as the number of edges incident with the vertex. So the degree of this X is 3, and he noticed each of the degree he studied, and he was able to conclude that each of the degree were not even. So he concluded that it is not possible to walk through all the bridges. So now we'll just look into some results under the different types of graph, namely what is a loop and multiple edges. So an edge whose endpoints are equal, we call it as a loop. So you can notice here, you take an edge. If the endpoints are equal, we call it as a loop. And similarly, we notice that what is a multiple edge? So in a multiple edge, the edges have the same pair of n vertices. So you can notice this is a multiple edge. So a loop means what? An edge whose endpoints are equal, and multiple edge means the edges having the same pair of endpoints. Now coming to the definition of what is a simple graph. So when a graph is said to be a simple, so you just know we have noticed what is the meaning of a loop and what is a parallel edges. Here there are two examples given here. A graph has no loops of multiple edges. So we notice that this particular graph, it has not any, doesn't have any loop and it doesn't have any parallel edges. So we call this as a simple graph. And here the first example, we notice that we are having a loop and parallel edges. So we call the first graph as a multiple graph, and this graph which is shown here, it is a simple graph. Now we can look into what is an adjacency and neighbors for a graph. So here we notice that two vertices are adjacent, namely this A and B are adjacent and they are neighbors. So adjacency means what? They are endpoints of an edge. So we say that the vertices A and B are adjacent when there is an edge, okay, which has the endpoints of an edge. So we notice that this vertices A and B are the endpoints of an edge, then we can say that A and B are adjacent. And here we notice that if you look into this A and D, we notice that this A and D, they are not having an edge as an endpoints, so they are not adjacent. So now let us look into what is when you call a graph as a finite and when you will call a graph as a null graph. So whenever a graph whose vertex set and edges sets are finite, we call it as a finite graph. And coming to the null graph, the graph whose edges are empty. In other words, we are having only the vertices, but the edge set is empty, we call it as a null graph. Now, let us peep inside what is the meaning of a complement of a graph. So, here is an example. You take a graph G, and if we are trying to draw another graph, we are just drawing another graph by looking into this G. So, we try to give the connectivity. Say U and V are connected means we are not going to connect this U and V. So, complement of a graph means what? We are just having all the vertices in G will be there in G complement. And looking into the adjacency, whenever U and V are adjacent, then they should not be adjacent in the graph complement. So, complement means what? We are getting a graph from a given graph such that whenever two vertices are adjacent in G, they should not be adjacent in G dash. Now, let us look into what is the concept of a bipartite graph. So, here is an example for a bipartite graph. And in this bipartite graph, we notice that the vertices are made as a parted set of G, and the vertices can be partitioned into two subsets such that each is independent. So, it means that, see, whenever we take the set of vertices in the set A and set B, if you are partitioning, then you take an edge. Each of an edge, you notice that it has an adjacency with the vertex in the set V1 and the vertex set in V2. So, here are two examples here. We'll peep inside the next concept about what is the meaning of a path and cycle in a graph. So, a path means it is a sequence of distinct vertices such that two consecutive vertices are adjacent. So, here is a graph and you can notice a path from that. So, we are having A, D and then C, B and then E. So, you notice that here is an example where we have noted what is a path and which is a path and which is not a path. So, path means what? Actually, the two sequence of distant vertices such that two consecutive vertices are adjacent. Whenever you are starting at a point and coming back to it, we call it as a path. So, let us now move to what is the meaning of a subgraph. So, given a graph, how we will define a subgraph? So, a subgraph means it is a graph, you given a graph, we take a subset of it, that is we collect the vertices and edges such that the set of vertices, that is B of H, will be contained in B of G, and the edge set will also be contained in your edge set of G. So, we will discuss an example here. So, how to write down the identify a subgraph. Okay. So, this is G is a graph and we are just taking two vertices D and C along with its edges. Similarly, here we have seen H2. We are taking these vertices along with the edges, and you notice that this H1, H2 and H3 are the subgraph of the given graph. So, subgraph means what? We are taking the subset of the vertices, the subset of the edges, and we are just writing it or drawing it out, then that is our required subgraph. So, now let us look into the meaning of connectedness and disconnected graph. So, when you call a graph as a connected, so we have seen about what is an adjacency of the vertices and neighbors of the vertices. So, let us peep inside what is meaning of a connectedness in a graph. So, if there exists at least one path between two vertices, we call it as a connected. So, here is an example. We notice that H1 is connected, H2 is connected. So, how H1 is connected? Because their default there is only two vertices, one edge is there. So, there exists a path between D and C. Now, coming to our H1, H2 here, we notice that if you start from A to D, is there a path? Yes. From A to E, is there a path? Yes, we can just walk through like this, A to B, B to E, there is a path. So, you notice that you take every pair of vertices, if there exists a path, we call that graph as connected. Now, let us look into this example H3. We notice that we are having component in that. So, H3 we are having two components, say AE is one component and this vertices BCD is another component. So, we can say this H3 is a disconnected graph. So, when you call a graph as disconnected, provided we are having components. So, now let us look into what is the meaning of adjacency, incidency and degree for a given graph. So, we call an edge as an adjacent. Here for example, we notice here EI is an edge whose end vertices are Vj and Vk. So, we can say that this EI is incident with the vertices Vj, this EI is incident with the vertex Vk. So, degree means what? The number of edges incident with the vertex. So, here we notice that this vertex Vj has a degree 1 and similarly this Vk has a degree 1. So, let us now look into what is an adjacency matrix. So, adjacency matrix means it is obtained from the given graph by writing out all the vertices. So, here is an example where we notice that there are 4 vertices, namely W, X, Y, Z. We are writing out row wise and column wise and we are looking into the end for each of this in this graph G. You look into W and with W, is there any end edges? No. So, we are putting a 0, we are marking 0 and we can look into W and X. W and X are connected. Yes. How many edges are there? There is only a single edge. So, we mark a 1. And similarly for Y and Z, there is no edges. So, we mark 0. And coming to the second row, how we are writing it out? X is connected with W, yes. So, we are talking about an undirected graph here where there is no direction. So, whenever we say a connectivity, either you can say that X to W there is an edge or W to X there is an edge. So, we are having, we are marking 1. And the next case, is there any loop with your X? No. So, we are marking 0 and coming to Y. How this X and Y, is there any arc? We notice here, there are 2 edges connecting X and Y. So, it is a parallel edge. So, we are going to mark it as 2. So, why we are writing it 2? Because there are 2 edges connecting this X and Y. In other words, there are 2 bridges between X and Y. So, we mark it as 2. And similarly, we are obtaining the other 2 rows by looking into the graph and looking for the incidency. Now, coming to the incident matrix. So, again an incident matrix means we are going to write the vertices and the edges, and whenever an edge is connected with the vertices, we are going to mark 1. And if there are 2 means edges, we are going to mark 2. So, here is an example for an incident matrix. So, incident matrix means what? Again, it is an n by m matrix in which the entry is 1 if Vi is an endpoint of Vi, and otherwise it is going to be 0. Now, we can look into here again the formal definition of this adjacency matrix is given. The mathematical definition, namely, given a graph V comma X, where the number of vertices are P vertices, then how do you write the adjacency matrix is given as follows, namely, it takes a value 1 whenever Vi and Vj are adjacent, it takes a value 0 otherwise. So, that is about our adjacency matrix. Now, let us look into some notations in our under the basic concepts, namely this delta and capital delta. This delta, it represents this minimum degree of a vertex, and this delta represents the maximum degree for a graph. So, usually for a regular graph, the number of maximum degree and minimum degree will be same. So, I have to say about what is a regular graph. So, regular graph means if all the vertices is of same degree, we call it as an regular graph. And here we can look into what is an order. So, the order of the graph is written as n of g and the number of vertex in g. So, whenever in a graph we are looking into the number of vertex, we talk about the order. And coming to an n vertex graph is a graph of order n. And the size of a graph is the number of edges. So, order means the number of vertices, size means the number of edges of the given graph. It is denoted by this notation. So, now we will look into what is the meaning of a complete graph. So, a simple graph we have taken, and here you notice that these two vertices are sitting in one side, and these three vertices are sitting in another side. And also you notice that each of an edge is identified with the n vertexes in the first parted and another n vertices in the second parted. So, a complete graph means what? It is a simple bipartite graph such that two vertices are adjacent if and only if they are in different parted set. So, if in a graph we are able to partition the vertex such that the edges are adjacent, when we talk about the vertices, if you are taking two vertices, they are adjacent if and only if they are in a different parted set. So, in other words, whenever you take an edge, the n vertices should be, one of the n vertices should be in the first parted set and another vertex should be sitting in the second parted set. So, now walk means what? A sequence of vertices and edges, we call it as a walk. And a trial means what? A walk in which the edges are not repeated, we call it as a trial. And here we have seen about a path means what? If in a trial, if the vertices are not repeated, we call it as a path. So, I just again highlighted what is a walk means what? It is a sequence of vertices and edges. A trial means what? A walk in which the edges are not repeated. A path means what? It is a trial with no repeated vertex. So, length means what? The number of edges in that path or walk, we call it as a length of a walk, trial, path or cycle. And again, when you say it as a closed trial or closed walk, if the end points are the same. So, now we'll look into a result, namely this is an important result when you say that you have learnt about graph theory. There are n vertices and k edges, then it has at least n minus k components. So, whenever a graph is having n vertices and k edges, there will be at least n minus k component. So, at least n minus k component means it can have n minus k or more than that. So, let us just peep inside some examples here. The first is an example where there are two vertices. Whenever there are two vertices and the number of edges is 1, we are having one component. So, when a graph is having two vertices and a single edge, we will have a single component. Now, if that graph is having three vertices and two edges, so it is having again one component, and here are the other two example where the graph is having three vertices and there are three edges, 6 vertices where we are able to identify there are 4 components. So this is a result under the graph theory, namely whenever a graph is having n vertices and k edges, then the number of components will be at least n minus k. So now we'll just look into what is the meaning of a cut vertex and cut edge. So for a given graph, if you are able to identify a particular vertex, so I have just you can see and highlights here, this is a particular cut edge. See, whenever you are able to identify a particular edge, if you are removing that, if you are able to get a component, then we call that particular edge as a cut edge. Similarly, the same thing holds for a vertices. Whenever you are taking a vertices and if you are removing that vertices, whenever we remove a vertex means what? The edges along with it will also be removed. So, if you are removing a vertex and if you are able to get a component, then we call that particular vertex as a cut vertex. So, here is an example where if you remove this E, we are able to get 2 components. So, we call this E as a cut edge. So, already we have discussed about this, namely what is a degree means what? A degree sequence. You take a graph and we are going to write down the degree sequence. D of W, what is the degree of this? We have noticed that it is 4. So, how many edges are incident? There are 4 edges, 1, 2, 3, 4. So, the degree of W is 4. So, if we are arranging the list of vertices in a non-decreasing order, so we will call it as a degree sequence. So, now we'll move to the Euler circuit. What is an Euler? A graph is Euler if it has a closed trial containing all the edges. So, we have seen about trial means what? It is a walk in which the edges are not repeated. So, Eulerian graph means what? If in a graph there is a closed trial containing all the edges, then we can say that particular closed trial as an Eulerian graph. Now, coming to the next concept under this Eulerian, namely whenever it is a closed, then we call it as a closed trial circuit when we do not specify the first vertex but keep the list in the cyclic order. So, in other words, whenever the end vertex, the starting vertex and end vertex are same, we call it as a circuit. An Eulerian circuit or Eulerian trial in a graph is a circuit or trial containing all the edges. So, if in a trial, if you are able to find cover all the edges, we call it as an Eulerian trial. So, here is another important, the second result which I am discussing with you all is about you take a graph, the sum of the degrees will always be equal to twice the edges. So, this is an important result. So, how we are proving this result? You know that whenever we talk upon an edge, okay, we identify the edge with the end vertices. So, each edge can contribute exactly what? Actually 2 degrees to the graph. So, if you take an edge, it will contribute 2 degree to the graph. So, the sum of the degrees will always be twice the number of edges. And we have seen about a bipartite graph. So, another result we can notice here, a bipartite graph, when a graph is said to be bipartite. So, a graph is said to be bipartite if and only if it has no odd cycles. So, you can see the pictures here, what is the example for the graph, where whenever there is no odd cycle, then it will be a bipartite. Otherwise, it is not a bipartite. So, what is a bipartite graph? If you are able to partition the vertices such that if you are taking an edge, one end will be in the first parted and another end will be in the second parted. So, here is an example for what we have discussed. So, we have discussed about a minimum degree vertex and maximum degree vertex. So, here is an example. You notice that the degree of 1 is 3, degree of 2 is 1 and 3 is again 3, it is 4, degree is 3, 5 is 4, degree of 6 is 2. And out of this set of degrees, we notice that the minimum degree is 1, the degree of the vertex 2 is 1. So, we say that delta equal to 1, that is the minimum degree is 1 and the maximum degree is what? 4. Here, the minimum degree and maximum degree are not equal, so the graph is not a regular graph. So, when we call a graph as a regular graph, provided the number of vertex of minimum degree and the vertexes of maximum degree are all same. So now we'll pass on to what is an independent set. So you take a graph. I hope that you all now able to identify and say what is a graph. So graph is identified by V comma E. So where V is a set of vertices and here we are taking X is a set of edges. So you take a subset of the independent of G we are taking. So S is a subset of V. So V is a vertex. So we are taking the subset of V and we call that particular subset as independent set of G if no two vertices of S are adjacent in G. So whenever the vertices are not adjacent, we pick all the vertices and we call it as an independent set. Whenever you are getting a case as follows, namely, an independent set is said to be maximum when it is said to be maximum provided if G has no other independent set. Suppose if S dash is another independent set means, then obviously the S dash should not, it should be greater than S. So this case should not happen. And coming to the number of vertices in the maximum independent set, we denoted by alpha. So this alpha is a notation where we say that it gives the number of independent set for a given graph. So independent set means what? You take a subset of the vertices and you notice that all the vertices we are taken in that subset will not be adjacent. So here is an example for an independent set given a graph with 4 vertices are there. Now we are going to look into how to find the independent set. So here particularly we are just noticing that this V1, V3, V4 are not independent. So let us make it as a set 1. And another set is there, vertices is there V2, V5 which are not adjacent. So again it is an independent set. And another set namely S3 is, we are noticing that V3 and V4 are not adjacent. So in this particular graph we are able to get 3 independent set. So if you are looking into the cardinality of this independent set, we notice that the set namely S1 is having the cardinality 3. So the value of alpha for this graph is 3. So in this lecture series, you all have learnt about what is graph theory and certain basic definitions with some result in it. In our next lecture series, I will be giving out some glimpse of the application of the graph theory. Thank you all.